So just a quick run through of what we're going to do. So we're going to make a custom tunnel. And the idea is that it's going to be a bit like VLAN tag, but plus, I suppose. So we're going to show you how to declare a header and then parse it. And we're going to do add and remove header as well to encapsulate and decapsulate. So the idea is here we are modifying the packets, and we should be able to see on the other end of our wire our new header. So we're going to define our header. We're going to change the existing parser. We're going to create actions to add the header, and we're going to modify our tables and our control flow to do that adding and removing. And we're going to run and debug and ship it, profit more apparently. Okay. Right. The code will speak for itself. So we'll see how P4 does parsing. Slightly more significant than we have now, and inserting headers, we'll see how trivial that is as well. And yeah, so it's largely the same, and if there's time we can have a look at adding a P4 counter. So we're going to have traffic coming in on P0 as before, and P0 is going to do the encapsulation, so we should then have on VF0 we should see our new header, and on the way back we should see the header removed, and in our physical interface we should then see the header removed. And that's pretty much that. Yeah. So the idea is not to start from scratch. We're going to use the previous lab as the base point. Okay. Right. So let's get cracking. Great. So here is our header definition, XLAN. You can see it's got a 32-bit tag, and as it encapsulates equivalent to VLAN, it's got the 16-bit ether type to identify the next header down the line. Okay. So right adjacent to the Ethernet header, we're going to paste in the XLAN header, and it's pretty much as easy as that. So next up, we have to we instantiate the header. Ooh. So we instantiate the header just as before, using the same convention. And there we have it. Okay, great. So now the header is ready to use. So we have to be able to use the header in P4, we have to describe how the header is extracted in the parse, and that tells the program what the layout is, where the thing is essentially stored in the packet. So if we scroll a little bit down to the second point. First thing we have to define our custom ether type. So we arbitrarily choose 9999, all hex. Great. And now we modify the parser. Okay. So the parser is basically in the Ethernet parse node, we're going to detect our fancy header, and then we create a new node called XLAN parse, and that returns to ingress. So, okay, again, copy and paste, and great, and that is it. So now, without very much effort, we can parse our new header. Right. So now we're going to modify the control flow to do the encapsulation. So remember, on physical port 0, we're going to do encapsulation and send it out on virtual port 0. Okay, and to do this, we're going to modify the existing code. So we take in table and we call it encap table. and we change it in two places, in where it's referenced and in the definition. And it's going to look very much the same. It's only going to match on ingress port, and we're going to have two actions, one to drop and one to forward, but we're also going to rename forward to something more, I guess, more suitable or less suitable depending on your view. Encap act. Right. So we modify that as well to encap act, and we save. Right, so at this point we're going to now call the same action as before. So we need to modify the action. Right. Okay. So again, copy and paste. And here we have our new action. So you'll see we've split it up into two. We've got the encap action, which takes a new parameter, and that parameter is the tag, the xlan tag, the 32-bit value. And now you'll see we modify the egress spec to forward the packet as before, and we call this new action called xlan encap. So you can stick P4 actions in other actions. And in this header, we do pretty straightforward stuff. We add our new header, we modify the field. Given, in this case, we are given the action parameter of tag, and we modify the ether type. You know, we copy the original Ethernet ether type into the VLAN ether the XLAN ether type, and then we set the Ethernet ether type to our magic 999 constant 9999. And in theory, that is pretty much done. So from P4 point of view, we're done with our encapsulation. So let's save. Ooh, this mouse is terrible. We save and we go to P4lab.rules. Right. So at this point, our tables are different. So at this point, you have to close your old rules and open up your file view, which has disappeared. Where is it? Project workspace. And P4 rules. And you'll have a, sorry, you have to build. That's right. Obviously, the table definitions haven't been updated. They've just been updated in the P4 source. So we have to rebuild. So those table configurations go in the IR, and then from the IR we can build on the rules from the rule viewer. So every time you change your tables, you have to rebuild to do your rules. So we'll wait a bit. Okay, great. We have now built, and we'll go through the process of closing the rules. We should have a refresh or something there, or maybe it automatically refreshes. Oh, okay. See, I'm not up to date. There we go. Fantastic. Encap table. So now we're ready to add our encapsulation rule. Okay. Okay. So we click add. And as before, we stick in a drop rule. So there are no matches for the default rule. So we just say drop action, and we are done. Okay. Right. Okay. Okay. So next, we want to add our new encapsulation rule. So we click add. We give it a name. encapsulate, encap 0, that's good enough. So here we specify the match. So we can then say which incoming port are we going to apply this rule to. And in this case, we're going to take the physical port 0 and apply the match there. Right. We want to select our new encapsulation action. And here you'll see we now have 2 parameters to the function. We want to forward it. Remember our wires from P0 to V0.0. So now we have the wire as before. And our tag, well, we can put anything in here. And I think for the purposes of this demo, there was a Hitchhiker's Guide to the Galaxy reference, so we'll persist with that. And we save. Okay. So I guess at this point I might just wait a bit, and we can go on and see the packet go through in a second. Okay. I've just done what someone else did. This is Windows 10, by the way. I've never seen the ability to detach the menu bar. Okay. Ooh. Okay. Let's try that again. Okay. We'll live with that. Okay, so we are hopefully ready to debug, or just run. Let's load it onto the card. Loading microcode. We can. I'll just wait for that to finish. Okay, fantastic. We have our setup ready to run. I'm not saying. Okay, we'll leave it up. Okay. So now we are running. Oops. Okay, great. There's a number of packets. Great. Okay. not meta. This rule's not applying. Rules P4. Just stop this. What tag? What's the mesh tag? Okay. Okay. Yep. Well, after much wailing and gnashing of teeth, I have my packet. So I think I know what's going wrong here. So it's IPv6 problem. So what's happening is there's a race condition on the load. So the firmware gets loaded, there are no rules. IPv6 packet comes in, gets cached. IPv6 packets come in constantly. In this case, it was just luck.
But it shouldn't, as I understand it, it should cache the correct behavior, not the bad behavior.
Yeah, no, this is it's a problem with how the rules are updated.
So it's not my fault, is what you're saying. It's an optimized way then. Yeah, that's suspicious. That doesn't sound
It could well be, it's likely inlined or something like that.
Oh, so you think it was like posted in inline or something?
Yep.
Okay, so that's
I would bring the interface down. I've done on the server. On it's P4 P1. No, don't you don't need to restart. bringing it down should be sufficient to stop those packets going out. And then the flow will time out, and then we'll be fine. Yeah, sure, why not? Anyway, okay, grand. We are ready to do encapsulation, hopefully.
If this doesn't work, then nothing else will work.
It's not. Right, so we move on past here, and we now define, we're going to define a slightly different control flow here. So our control flow is going to be different in that there's a conditional on whether XLAN has been extracted. So this is, I guess, a non-table-based control transition. So if VXLAN has been extracted, then we decap it, or we apply a decap table to it. We may drop it or not, or decap it, and otherwise we do the encap. So now let's define our decapsulation table. So we snap that code into the PS code. And we save it. Great, and it works pretty much as before. It also matches on the ingress port, but we could just as easily define in here a match based on the XLAN tag. Great, and we reference this decap action, which will pull out the document again. Right. Okay, great. So now we have decapsulate in our data plane. So now we build it. So the decapsulate is pretty straightforward. Again, we forward as before. In this case, we copy the XLAN ether type, the inner ether type into the Ethernet ether type, and then we remove the header. Right. Did that work, the IF down? Okay. Okay, great. Now we have a firmware. Now we need to add our new rules to encapsulate the packets coming in the other direction from the VF to the physical. So we go to our rules editor as before, we click add, we give them all a name, we call that this default drop, set it as the default rule, it's going to apply when other rules don't, and we specify this as a drop action. Oops, one too many. Okay, and now we add a new rule. We'll call it decap 0 is good enough. And decap 0 is going to apply to traffic coming in on virtual port 00. Okay, and we decap it, and the decap action just has the port, the egress port parameter. So we wanted to put that out on P0. Okay, great. Mistake. What have I left out? Did I give you the right one? Okay, that worked that time. Don't know what I did. Okay. So now we have our decap action ready to go. So let us start. Let's just kill our TCP dump here. And let's start debugging. Ooh, one thing I wanted to do in this case is just I've done P4, P1. Okay, that's fine. Right, so we wait for it to load, and we reflect. Okay. Oh. Okay. Okay. So now if we click run, we should in theory be able to encapsulate as before. Let's get rid of the breakpoints. Not interested in those. Okay, great. So we are listening. Right. Okay. Okay. So we're still in the same flow. These IPv6 packets, you just can't kill them. They just don't go away. Yep. Yeah, we've done that. Well, yeah. It doesn't work. I wonder if it's happening in the NIC somehow.
Usually not.
Let's try that again. Okay. Well, it's still using the cached action. Anyway. Okay. Okay, so we kind of got our encap tested last time, so let's try our decap. So in /root, you'll find pcap xlan.pcap. And we must just make sure it goes in on the VF0. And it should, in theory, come up here if we click run, I guess. Okay, let's try that again. It's running. RX packet. Okay, it did actually RX. Why didn't it display it? Okay. I guess it was taking its time. Well, there it is. You know what? Name resolution was on. So this should make it a little bit quicker. There we go. Much more satisfying. So there's our decapsulated packets. And if you don't believe me, there we have it. Yeah, that was the tag in this case for this. So there we've got our L2 stuff. There's our. This is the tag packet.
There's our E-type, not
Yep.
Yeah, okay, got it.
Yep.
Cool. And so on the other end, we're getting decapsulated.
Yep. Okay, how's everyone doing? So at this point we can add P4 counters. Should we try that? Anyway. Okay, P4 counters are really easy to add, so I'm going to create just 2 for fun, with a very low definition of what fun is. But okay, so here we go. Encap and decap, 2 different types. One's going to count packets, one's going to count bytes. P4 allows you to set an array of these things, so you can specify 128, and then within your P4 action, you can use a number of bits of data as the offset, either constant or from action data or from a field. But in this case, we're going to stick with one. We are going to add it to our P4 source. I would put it before the actions. There we go. And when we go and actually do the count, it looks a bit like this, and it's just basically count the counter name and the index. So we have 1 counter, so our index is stuck at 0. So we can stick one in here for encap. And then we can stick one here for decap. Okay, as easy as that. So let's try. Quite right, quite right. Sorry. Okay, and that's all that's needed. And now we can start debugging. Okay, excellent. So we are good to go. Click run. And now in theory, it should be counting all these stinking IPv6 packets. So let's see how many of those have arrived. Okay, just a quick note on counters. I don't think we covered this before. We've got 2 types of counters. System counters, which are present, whether they're in your P4 source or not. And there are P4 counters, which are you explicitly code them up. So in this case, we see nothing here, but as per usual, we click, did it rebuild? Oh, looks like I missed the rebuild step. Sorry about that. Save, rebuild. Okay, let's try that again. There we go. Great. There we are. Refresh the counter. Ah, 3. Great. And they're all being dropped. But that should make this better, a slightly better. Ooh. Oh, maybe not. Right, of course, they're being dropped, so they're not hitting our action, which they're not being counted. So the reason this display is like this, because you can have many kind of, I guess, hundreds of counters in theory, it collapses them if they're all 0. So if we put a packet in the reverse direction, which isn't polluted by IPv6, here we go. Right. In this direction, stick a few in. We refresh, and then lo and behold, 320 bytes. And if we just kill. So can someone explain to me why IPv6 packets are still coming out on the fortful, even though the interface is down? That's mind-blowing. Okay. Yep. Stop.
It is very annoying.
Okay. So with some luck, we've created a new protocol. We've managed to insert it and then decapsulate it on the way back with some counters in between.